From a height of a building, a ball is thrown downward with an initial speed of 8 meters per second. That is, the initial velocity is minus 8 meters per second. And then it goes down until it hits the ground. What is the time interval does it take to hit the ground? And what is its final velocity in there? To solve the first part of the problem and find the time takes the ball to hit the ground, we have to look at the information we've got from the problem. We have the initial velocity is minus 8 meters per second, and the height of the building is 30. That's why delta y is minus 3 as the ball is going down. So the displacement has a negative sign, and obviously g, acceleration due to gravity, is 10 meters per second square. From this information, we need to use the equation delta y equal the product of initial velocity of time minus half g t squared. We substitute delta y minus 30, as we said, because the ball is going down, so the displacement is negative. And also we put minus 8 for the initial velocity as the ball is going down. And then we'll get sort of this quadratic equation, which is look like this standard quadratic equation. So the solution is this, which corresponds to the standard solution of such quadratic equation, and the time obtained here is 1.77, which is the time of the trip of the ball as it reaches the ground. To find the final speed as the ball hits the ground, again we have to check the information we have from the problem. We have initial velocity minus 8 meters per second, and delta y is minus 30 as it goes downward, and we know the height, and g is 10, and we need to employ the equation of square of final velocity equal the square of initial velocity minus 2g delta y. As we have initial velocity and delta y, we substitute all these information in here, and we've got a final velocity with a plus minus sign. Obviously we're going to take the minus sign because the velocity, or because the ball is going downward. The final speed, the word speed, it means the magnitude of the velocity, and the minus sign, as I said, refers to the direction of this velocity. From the same building of height 30 meters, is going to release the ball from rest. That means, initial velocity is 0, and then we're going to find the time it takes the ball to reach the ground and its final speed at the ground. Again, looking into the information we have from the problem, where t initial equals 0, the initial speed is 0. The displacement we have as ball goes down from a height of 30, so displacement we have minus 30 meters. And also we know that the acceleration due to gravity is 10 meters per second square. We use all this information to together with the equation of delta y equal the product of initial velocity of time minus half gt square. Obviously, the only difference between this problem and the previous problem is the initial velocity. The initial velocity in here is 0. So finally, we're going to get a time of 2.45 seconds. That is the time of the ball as it strikes the ground. Also, to find this final speed, again, we'll use the same information as we had before. Of course, if you like, together with the time obtained. But in this case, it's easy to use this equation as the previous example by substituting all the values, and we are going to get two signs for the velocity. I'm going to choose the minus sign. The magnitude of the speed is 24.5 meter per second for the final velocity, and the minus sign, as we said before, it refers to the direction of the velocity downward. There is one further part necessary to solve, is to find the location of the ball after 1 second of its release. Again, we're going to use the same information and employ the equation delta y equal to the product of initial velocity with time minus half gt squared. In this case, we're going to substitute 1 second for the time in order to find the displacement at this time, and we're going to get a displacement of minus 5 meters. This means that the 5 meter below the top of the building. So this is the answer for this part of the problem.